Hello and welcome to another part of Unreal tutorial for top-down game, and this time we will be adding the first enemy. We will talk about animation events and hit detection. After this episode we will have a skeleton in the game and we will be able to attack it and print a string on a hit. So let's get to it. At first we will have to import the sprites for the skeleton as we did in the previous episode. So in the characters, create the sprites folder, and there in the sprites folder click the import and find the sprites for the skeleton. As always, you can find the link to the sprites in the description of this video. These sprites are organized in the down, up, left, right folders, and we have to import all the sprites from all the folders, so let's do it. I will just fast forward here, but once you are done, you have to select all the sprites and right click on them and hit the sprite actions and apply paper to the texture settings. Each sprite contains multiple animation images and we have to get those animation images from the sprite. So let's start with the idle animation. We can write idle to the search sprites to just filter those idle animations and right click on the first one, and in the sprite actions choose the extract sprites. In the settings we will choose the grid sprite extraction method and set the cell width to 48 and cell height also to 48 pixels. Then we can change the template name so we can orient in the sprites better. And we can use, for example, skeleton idle down. After that, you can click the extract button and you will have those sprites separated. We now have to do that for all the other directions, so also for the up, left and right sprites. I will again fast forward so we do not waste time here. Once you are done, you should be able to search for the skeleton idle and get all the idle sprites for each direction. We now have to create flipbook from that, so select first 6 sprites and hit the create flipbook and name it FB skeleton idle and the direction, in our case, down. We now need a place where to store these flipbooks, so in the characters folder we will create a new folder there called skeleton, and we will move our newly created flipbook to this folder. We now have to repeat this creation of flipbooks for all the other directions and also move the flipbooks to the skeleton folder. So I will again fast forward here. But in the end you should have 4 idle animations in the skeleton folder. Once you are done with that, we can continue with that animation, and we will do the exactly same thing as before. We will select one of the dead animation sprites and we will extract sprites from that. We will again use the grid method and 48 pixels cell width, and again change the name template to skeleton depth and direction. And after that we can hit the extract button and this will create sprites. So we will repeat this for all the directions. And I will again fast forward that. Once we have all the sprites for all the directions, we have to create flipbooks from them. So let's search for the first one, for example that down, and select all the sprites and hit the create flipbook and name the flipbook as FB underscore skeleton dead down. And we will again move it back to the skeleton folder. And we will repeat this for all the directions. So again, I will fast forward to get the results faster. In the end, you should have 4 dead animations and 4 idle animations as shown here. As a next step, we have to create the animation source. So right click on the skeleton folder and search for the animation source and create new one. And let's name it AS underscore skeleton. In the animation source, we will create new animation sequence. The first one will be called idle. We will hit the multi-directional sequence button as we did in previous episodes. And for each direction, we will search for the right flipbook for the idle animation for this particular direction and set it there. I will again fast forward to the end result. So in the end you should have 4 animations set properly. Next we will create the animation sequence for the dead animation. So let's create new animation sequence and call it dead. As before, click the multi-directional sequence button and add the right animation for each direction. I'm again using fast forward to get to the result. So in the end there should be 4 animations set properly. Now we have to create the animation blueprint to define the transitions between the animations. So let's right click in the skeleton folder and select the paper ZD AnimBP, and there we will select animation source skeleton. We can name this animation BP as ABP skeleton. We will open this animation blueprint and we will also open our animation blueprint for the hero character because we will be copy pasting code from that. Let's switch to skeleton animation blueprint and to the animation graph section. And in the animation graph, we will create new state machine called locomotion. So right click, select the add new state machine, call it locomotion, and connect it to the output animation result. Now we will open the state machine and create new animation state there. So right click on some empty space and search for the animation state. And we will call this animation state as idle because it will be state for our idle animation. It will be the default state, so let's connect it to the out jump. We will use the exactly same logic as we use in the animation blueprint for the hero. So we can see that we have two variables there, last velocity and speed. So we will have to create those also in the animation blueprint for skeleton. So add new variable there called last velocity and set the type to vector. And also add a new variable called speed and set the type to float. Now we have to copy the code to set these variables on every tick. So let's open the event on tick. And in the blueprint animation for hero, also open the event on tick. And we will copy and paste this code from the animation blueprint hero to animation blueprint skeleton. And we will call it from that event on tick event. Now let's go to the animation blueprint hero and open its anim graph, locomotion and idle. And we will copy the set directionality and last velocity get action. And we will add it to the skeleton to the idle state. And we will also add the play idle animation and connect it to the set directionality and set directionality to the output animation. That way we will play the idle animation for the skeleton depending on the direction the skeleton is facing. We can now add the dead state. So let's get to the locomotion and we will add new jump node. And we will call this jump node dead. Then we will add new animation state and we will call it dead state, and this will be where our dead animation will be played. We need to also add the transition between the dead jump node and the dead state, and now we can open the dead state. The code in the dead state will be the same as in idle, so we will copy the set directionality again from the idle. But instead of play idle, we will play the dead animation here. So right click and search for the play dead, and we will also disable the loop animation there because we want to play this animation just once. So now we have the idle and dead animation ready, and we also have the animation blueprint to switch between these animations. Next we have to create the character blueprint for our skeleton so we can add it to the game. As we did with a base item, we will use the BaseEnemy class to represent any enemy including the skeleton. So in the characters folder, right click there and choose the blueprint class. In the next menu, choose the character. And we can name the resulting class as a BC_BaseEnemy. Now open that class and we will add new components there. So the first component to add will be the flipbook. So search for the paper flipbook and add it there. Next we will need the paper ZD animation. So search for the animation and add the paper ZD animation there. In the paper ZD animation in the right menu, we will change the anim instance class to animation blueprint skeleton, and also the render component ref to the paper flipbook. So the paper flipbook is changed according to the animation blueprint skeleton. Now in order to see some preview here in the viewport, we need to also go to the paper flipbook and change the source flipbook to some flipbook. It's good to use the same one as the enemy we are working on. So use the skeleton idle down. And you can see the skeleton is facing wrong direction. We have to rotate it 90 degrees so we can see it properly from the top. And I think we also have to rotate it to the left because our X and Y axes are swapped, so that way it will be standing properly. Now we can try adding that enemy class to the game, and we can see that it's standing on its head, which is not what we want. So let's get back to the blueprint and rotate it to the right. And I think now it should look better. So let's go back to the game viewport and we can see it's standing on its legs as it should. It's super small, we will have to fix that, but otherwise it looks good. So to fix the size, let's simply get to flipbook and scale it by 2. We can now run the game and we can see the size is okay, but the collision works a little bit weird and the skeleton is overlapping the hero, so let's fix that. We can change the view mode from the perspective to the top to see it from the top-down mode. And we can use the move tool to move the flipbook a little bit up. Now we will try to fix the rendering order. In one of the previous episodes called Sprite Rendering Order, we have enabled the Unreal feature to set the rendering order of the sprites based on the y-axis, but this only works with a translucent material, so we have to change the material of this flipbook to translucent unlit sprite material. If we run the game now, we can see that the skeleton does not overlap the hero anymore. But the hero cannot go behind the skeleton, so let's fix that as the next thing. Let's go back to BaseEnemy and click on the capsule, and we will make the capsule radius smaller so the player can actually go behind the skeleton's head. We also should move the skeleton a little bit up so the capsule is on his legs. And now we can try playing the game, and I'm quite happy with the end result here. We can now start working on the hit detection. It will work like this. We have our animation frames for the attack animation, and in Unreal we can set up notifier for any frame of the animation. It will simply call our animation blueprint for the notifier when the animation frame is shown to the screen. We will create new notifier called ANHit, and this notifier will do the following. It will create a box and it will check for all the characters inside the box to detect whether there was anything hit. So let's do that. In the characters folder, create new blueprint class, and in the next menu search for the anim no, like anim notifier, and then search for the paper set the anim notify and click the select. And we can name this resulting class ANHit. Now we have to run this animation notifier from the hero attack animation. So in the characters hero folder, open the animation source hero, and there we will open the attack animation sequence, and we will try to decide in which frame we want to add the notification. So let's stop the animation and go frame by frame and use your best judgment to find out like which frame represents the attack the most. So maybe it's the first frame actually, or second. Maybe let's try with second frame. So on the second frame, we will right click the one row and add the ANHit notification. And actually checking the difference between the first and second frame, I think it's actually best to move the notification back to the first frame. So drag and drop it and move it to the first frame. So now at any time this animation is played and the first frame is shown on the screen, the animation notifier will be executed. So let's go to the animation notifier definition and try to edit it. So let's open the characters folder and open the ANHit, and we will add new code there. If this screen opens to you, let's click on the Open Full Blueprint Editor link. Here we have to go to the functions and select the override and click on the onReceiveNotify, which is the function executed on that first frame. We want to create a box here and detect all the actors in the box, but in order to see the box, we will use the draw debug box action at first. And in order to see this box, we will change the thickness to some big number and also the color to some yellow color, so it's quite visible. We also have to set some size for this box, so let's change the extent to 15 as an initial value. And we can compile this and move to the animation source hero. And if we run the animation now, we should see the box appearing at the first frame. What we need to do now is to change the code so the box appears exactly where the sword is, no matter what the direction of the animation is. To do that, we will use the sockets, which can be set for each frame using the sprite, which is used as a source for this frame. So let's search in the characters hero sprites for all the attack sprites, and search for the attack one, which is like the first sprite. And we have to open all the sprites for all 4 directions. So let's switch back to the code view, and in the attack down sprite, we will add a new socket. So let's find the socket section and click on the plus sign. And we have to move this socket to the center of the sword animation. We also have to name this socket as a hit socket. And we will do the same for the other 3 directions. So let's open the attack left sprite and also add a new socket there and move it where the sword is, and also rename it to hit socket. I will use the fast forward here to save some time. Now we have to use this socket from the animation hit blueprint. So let's get there, and we will change the center of the draw debug box and get it from the socket location. At first we need to get the getSequenceRenderer component action, and from that we will get the socket location. In the getSocket location we need to set the socket name, which is our hit socket, and the return value is the location of the socket, which should be connected to the center of a draw debug box. We can also make it less thick and change the extent to 10 to make it smaller. It's very important to hit the compile button every time you change anything here. So hit the compile button, let's go back to the animation source hero and run the animation. And you can see that the box appears on certain location, and if we switch animation to different animation sequence, it will appear on different location. But we also have to change the size of the box so it matches the sort. To do that, we have to go to the draw debug box and experiment with the extended numbers. So for example, change the X from 10 to 20. Hit the compile button and run it, and you can see that that's too much. In the end, after some experimentation, I found out that the number 13, 10 and 7 are good. The issue is that it only works for up and down animations, but if you go left or right, we would have to rotate the box. We would have to use different box sizes. So we cannot just hard code the box size in the animation hit like that. I'm open to some better solutions, but for me, the best solution so far is adding new socket to each sprite for the frame. And we would use this socket just to store the size of the box as a location. So you can see that location right now it's 0, 0, 0, and we will use that numbers 13, 10 and 7 there and get the numbers from that. So let's name the socket as hit socket size, and as a location set the 13, 10 and 7, which is the size of our box. Then we will open the attack app and we will do the same thing. We will add new socket, name it hit socket size, and as a location we will use the 13, 10 and 7 because that's the size of our box. Now we have to find the right box size also for the left and the right attack animation. So let's get back to the animation hit and try to use 7, 10, 13 and compile it and go to the animation sequence and see how it looks like. And we see that it's probably too big, so we have to decrease some numbers there. Let's get back to A and hit and try 7, 10, 10, and I think that will be better. We also have to click the compile button, and now we see it's better, but it's in the wrong position. So let's get back to the attack left sprite and move the hit socket a little bit down to the center of the sort, and also add that additional socket to store the size as a location. So let's name it hit socket size, and as a location we will use the 7, 10, 10. And we will do the same for the right animation. So let's switch back to the right frame and move the hit socket a little bit down to the center of the sort, and we will add another socket which is named hit socket size, and for the location we will use the 7, 10, 10. Now we have to use these new sockets from the ANHit class, so let's go to the ANHit blueprint and we will add more code there. We will copy paste the sequence render component, but from that this time we will use the getSocket transform. The difference between the getSocket location and getSocket transform is that the getSocket location returns the coordinates relative to the world. It's like global world coordinates. But in the getSocket transform, we can define the transform space and set it in the way that it always returns the number we set there, no matter what the world location is. So we have to set the transform space to the RTS parent bound space, and we will set the in-socket name to hit socket size, which is the name of our socket. Now we have to split the struct pin in the getSocket transform and get the location value and connect it to the extent. Don't forget to compile, and if we change the animation source now, we can see that the size and position of the box is correct. Now we can finally add the code to detect the actors in the box. So in the animation hit, we will add new action called box overlap actors. And we will use the getSocket location as a box position and getSocket transform as a box extent, the same as we use in the draw debug box. We will draw a line from the object types and add the make array action and set the variable to pawn, because each character is a pawn. And we will also set the actor class filter to the character because we only want the collisions with the characters. So this should be enough to detect the actors when we hit something. We now want to print the actors, so take the out actors and use the for each loop action. And for each array element, we will use the print string action to actually print it. So we can now run the code. When you press the F key, the hero will attack, and if you press the F key close to the skeleton, it will print the string BC base enemy. Sometimes it also prints the top-down character, which means we hurt ourselves, and this is not what we want, so let's fix it. We can use the actors to ignore from the box overlap actors input and set it to the actor which triggered this animation notification. So let's get the owning instance of that onReceive notify and use the get owning actor and simply connect the result of the get owning actor to the actors to ignore in the box overlap actors. It will automatically generate an array and add this variable there. We can again try running the game, and if we hit the F key, we should never hit ourselves and we should still be able to hit the skeleton. Now, the hitting skeleton is somehow rough, so let's try to see what's going on there. To debug that, we will set the duration of the draw debug box to 5 seconds, so the box will be visible in the game for some time. If we run the game, we can see that there are two issues. The box orientation is wrong and the box size is also wrong, so let's fix those two. The box orientation is wrong because our axes are swapped. We have X pointing up and Y pointing right, so we also have to swap the axes in the code. What complicates it even more is that these sockets also use different coordination system. They have like different axes than what we use, so the best way is to experiment with that until you get the right result, to be honest. Anyway, we have to remove the lines from the extent input variables, and we have to use the split struct pin in the draw debug box and also in the get socket transform. And now we have to connect the X location to the Y, and then Z location to the X and Y location to the Z. And we have to do the exactly same thing for the box overlap actors. So connect X to Y, Y to Z, and Z to X. Now we can try running the game, and we can see that the box orientation is okay, and the only missing part is the size of the box. There is a simple explanation for that, and let's open the top-down blueprints and top-down character. And there you can see that the scale is 3, so we are scaling our main character by 3, and therefore we also have to scale the box by 3. So in that hit socket size, we will basically multiply each number by 3 in all 4 frames. And if we play the game now, we can see that the size and also the rotation is correct, and we can hit the base enemy, we can hit the skeleton. So that's all for today's episode. I hope you liked it, and in the next one we will implement simple damage system and we will be able to kill the skeleton. So as usual, please subscribe and see you next time.